Okay, when we're looking at rational expressions, rational meaning fraction, I always tell people think of your rules of fractions. So in the beginning here, we're just simplifying fractions. So if you think about it, when if you were to simplify a fraction, think of like 24 ninths, right? You would divide top and bottom by 3, get 8 over 3, right? So you're dividing something on the top, on the bottom, getting, a common factor basically to cancel. So you're getting a factor of 3 to cancel. Well, with expressions, with algebraic expressions, you basically have to have common factors. So that lets you know things need to be factored. So here I'd pull out a z, get z minus 3. On the bottom, I'd have to notice that that's a difference of two perfect squares. So plus, minus, square root of 9, 3, 3, square root of z squared, z, and z. Now, you probably remember from last year, if you have z minus 3 and 3 minus z, notice the z's have opposite signs, the 3's have opposite signs. This can then cancel to negative 1 over 1. So that's negative z over 3 plus z. You cannot cancel these z's. This is joined by a plus sign. It's 3 plus z. So you cannot just cancel the z's because of that plus. If there's a plus or minus, that makes it terms. So you cannot cancel these. That is your answer. Next one, on the top, pull out a y. Y squared plus 4y minus 21. On the bottom, it's a difference of two perfect squares. So y plus 7, y minus 7. Now, on the top, we have a trinomial. Leading coefficient is 1, so that's nice. We just need to get what multiplies to 21, negative 21, and adds to 4. So 7 and 3, we would want plus 7 minus 3, so that it adds to 4. So that means these factors can cancel. So remember, I can't just cancel the y's and cancel the 7's, but I can cancel an entire factor of y plus 7 with a y plus 7. Factors, remember, are things that are multiplied. So since all of these are being multiplied, y plus y plus 7 plus y minus 3. And this is y times y minus 3 over y minus 7. Okay, next one. On the top here, I have to recognize that's a difference of cubes. So to get a, remember, I do the cubic root of 8x cubed, which is 2x. And to get b, it's the cubic root of 1, which is 1. So then I go a minus b, a squared, plus ab plus b squared. On the bottom, I have a trinomial whose leading coefficient is not 1. So this is where I got to do a little guess and check. So I put 2x and x. The only thing that's going to multiply to give me 3 is 3 and 1 or 1 and 3. So I have to determine the order. If I put the 1 here and the 3 here, outers give me 6x, inners give me 1x. Those will add to the 5x if I make it plus minus. So I want plus 6 minus 1. The nice part with rational expressions is you can kind of I know that I might want these to cancel. Like if I have a 2x minus 1 on the top, a lot of times you're going to have a 2x minus 1 on the bottom rather than like put the 3 over here and have 2x minus 3, then those wouldn't cancel. Doesn't always work out, but sometimes like you can kind of tell by the problem, okay, what's going to cancel with something on the top? Maybe I should try that first. Okay, and then we have okay, so now we go from just simplifying to multiplication of fractions. So let's think, I'm going to kind of go down here and think about what if you were multiplying two fractions? Well, when you multiply fractions, you multiply straight across, but you always reduce if you can. So this would be like a 5 over 1. This would be a factor of 3, factor of 3. Then you would go straight across, right? So same thing with this. We're going to, we could take a factor of 9 out of here. That's 1. Factor of 9 out of here. That's 3. Y to the 3rd and a y to the 8th leaves you a y to the 5th on the bottom. Take a 4 out of here. That's 2. 4 out of here is 3. And this leaves you an x on the top. So we got 2x over 3 times 3, which is 9, y to the 5th. Okay, now those were just monomials. They were just one term, so I could just kind of go right to canceling. As soon as it's more than one term, you are going to need to factor, because remember, you can't cancel like just if you have a binomial or trinomial, you can't cancel the terms. You have to have factors. Where the last example, we did have factors. They were all just like, this is 8 times x cubed. Going back up here. So this is an 8 times an x cubed. This is 12 times x squared. So they're factors. Okay, so here we have to factor on the bottom. I've got a difference of 2 perfect squares. On the bottom here, I have x minus 3, x minus 3. So that's a trinomial. Leading coefficient is 1. I need what multiplies to 9 but adds to -6, which would be a -3 and a -3. So one factor of x minus 3 on the top cancels with one factor of x minus 3 on the bottom. One factor of x plus 2 cancels with one factor of x plus 2. So I have a 1 on the top because now I multiply straight across, and then x minus 2, x minus 3 on the bottom. All right. Okay, now we have division. We should know that when we're dividing fractions, we multiply by the reciprocal. Now, to save some, writing, I am going to factor as I write down the first fraction. So the first fraction, I'm going to pull out a y. So I have y squared plus 2y plus 4. On the bottom, I'm going to factor out a y squared. So that is then y plus 2. Then I'm going to do times, and I'm going to flip this. And when I flip it, I'm going to factor as well. So if I'm bringing this now up top, it's a difference of 2 perfect squares, so I'm going to factor it to y plus 2, y minus 2. And this one I'm bringing down on the bottom. It is a difference of 2 cubes. So I'm going to say, so remember, a would be the cubic root of y cubed, which is y, and b is going to be the cubic root of 8, which is 2. So a minus b, a squared plus ab plus b squared. All right. So now we're going to have a lot of things that cancel, right? So the y squared plus 2y plus 4 on the top cancels with the y squared plus 2y plus 4 on the bottom. Y plus 2 cancels with the y plus 2. y minus 2 cancels with the y minus 2. And the y over y squared cancels to giving me a y on the bottom. So when I multiply straight across, I have 1 over y as my answer. All right, now we're going to look at some adding and subtracting of fractions. So we have to think about how we add and subtract fractions. If I had, let's say, 3/4 plus 5/3, right? If I were going to add fractions, and we actually kind of reviewed this earlier in the unit, but I would have to get a common denominator. 4 goes into 12 3 times, so I'd multiply top and bottom by 3. And here, 3 times 4 is what gives me 12, so I'd multiply by 4 here, get 20. Then what happens is you add the numerators, keep the common denominator. So that's the process that we're going to use when we come over here. First of all, I have to know what is the common denominator. So I have to know what's in common to these denominators. So I have to factor x, 3, 1, minus 3 plus 1, so that it adds to -2, multiplies to -3. The bottom of the next one, that's a difference of 2 perfect squares. So x plus 3, x minus 3. So let's see. We have an x plus 3 as a factor, we have an x minus 3 as a factor, and we have an x plus 1 as a factor. So that's what we need as our common denominator for all of these. So looking at that first fraction, it had the x minus 3, the x plus 1. So it needs the x plus 3. So if I do that on the bottom, I have to do that on the top as well. So I have to distribute this. This becomes -2x minus 6. This had the x plus 3 and the x minus 3 down here. So we need the x plus 1. And if I put that on the bottom, I have to put it on the top, distribute. 3x plus 3. So sometimes one of the confusing things for people when they're doing multiplication and division and then they switch to addition and subtraction is that, we don't want things factored in the numerator. Normally with multiplication and division, we leave it factored so we can cancel the factors. But if you remember with addition and subtraction, you have to add your numerators. The only way to add my numerators is if they're terms. So this is going to be x minus 3. So I'm adding these. I'm adding the like terms. And then over x plus 3, x minus 3, x plus 1. Now this goes back to what we did in the very beginning of the notes. If there's a common factor on top and bottom, I can reduce. So my answer is 1 over x plus 3 times x plus 1. Okay, next one, same thing, but subtraction. So x plus 4. This one is x plus 4, x minus 4, difference of 2 perfect squares. And then here we have an x. So and we've got 3 fractions here. So we need x plus 4, x minus 4. X plus 4, x minus 4. X plus 4, x minus 4. Okay, so the first one has the x and the x plus 4, so it needs the x minus 4. So that's 2x minus 8. This has the x, but it needs the x plus 4 it needs the x plus 4 and the x minus 4, which is x squared minus 16, right, if you FOIL that. And the last one has the x plus 4, x minus 4, but it needs the x. So that'd be 5x. Now, here's where you have to be careful. This binomial follows a subtraction sign, so you need to distribute. So it is 2x minus 8 minus x squared plus 16, and then minus 5x over x plus 4, x minus 4. So on top, we get a negative x squared minus 3x plus 8. That's just adding like terms over x plus 4, x minus 4. Now, on the top, normally you would factor, see if anything cancels with the bottom. I can tell that the top is not going to factor. Nothing multiplies to 8 that adds to 3. So I'm done. Okay. All right, and last type we have here is where we have a complex fraction. That's a fraction in a fraction. So what I want to do there is multiply by LCD, least common denominator. So what you do is you scan the denominators. We've got x, y, x squared, y squared. So if I were getting a common denominator, it'd be x squared, y squared, right? That's what everything would go into. So I'm going to multiply top and bottom by x squared, y squared. Since there's more than one term in the numerator and the denominator, I have to distribute it to both. So basically what happens is I'm multiplying all 4 terms by x squared, y squared. So here, the x, that leaves me an x there. If I were multiplying these two, the x's could cancel and I'd have an x in the top, nothing on the bottom. If I'm doing these two, a y is going to cancel. These two, the x squareds cancel. These two, the y squareds cancel. So if I'm thinking of what I have here in this first, I now have xy squared over 1, which is just xy squared. When I do the second two on the top, when I multiply those, I have plus, it was plus, right? Yeah, plus x squared y. On the bottom, I have y squared minus x squared. So now it just becomes exactly what I had in the very first problems I was doing, where I have to factor out a GCF here. That's the only way to factor this, is pull out a GCF. I have y plus x. On the bottom, that's difference of 2 perfect squares. So plus, minus, y, x, x. Those cancel. And my answer is xy over y minus x. All right, last one. So this is over 1, this is over 1. So it looks like x minus 4 is what I want to multiply every term by. Okay, so on the top, I distribute that. It's 2x squared minus 8 plus here, those cancel. So 13x minus 3. There, 2x squared. Oops, sorry, minus 8x, that should be. Yeah, sorry, this is minus 8x, this is minus 8x. Because the 2x minus times the negative 4. These cancel, I get plus x plus 3. Now, sometimes people are tempted to cancel 2x squared they want to cancel these 2x squareds. They want to cancel these negative 8x. No, they're terms. They're joined by a subtraction sign, so you can't. In the numerator, what you want to do is just combine your like terms. Same thing in the denominator. And then the last thing you have to do is see if you can factor cancel. So I want a 1 here and a 3 here. So my outers are 6x, inners 1x. Those will add to 5 if I do plus 6 minus 1. And with this one, I want 2x, x multiplied to 3 is again 1 and 3. And if I check my outers, 6x, my inners, 1x, those will add to negative 7 if I make them both negative. Those cancel. X plus 3 over x minus 3 is my answer. I cannot cancel those. They're not the same factor. One has a plus, one has a minus in the middle. Okay, that's it for day 7.